Hello students, welcome to day 39 of PU2 BRAHMASTRA series. So as you all know, we have completed all the chapters and now we are on the journey of revision, and to revise organic chemistry, the best way you can do is to practice conversion questions, right? So welcome to part 2 of organic conversions, and today we will be taking the conversions from the chapter aldehydes, ketones and carboxylic acid and amines. Okay, some 30 plus questions you'll be getting in this class, and if you do all these questions, definitely you can remember the reactions very well. Okay, so without any further delay, let's get started, my dear students. So chapter name is here and the first question is in front of you, and you need to do these questions. Okay, and let us start doing them very quickly, and if you are able to do it, put a comment yes or put a thumbs up and let me know that you are able to do it, and if not, please watch the solution and try these questions once again. Okay, so how will you prepare the following compounds from benzene? Okay, the starting material is given to you and that is benzene. You may use any inorganic reagent and any organic reagent having not more than one carbon atom. Okay, fine. So I need to prepare from benzene. Okay, I have benzene and I want to prepare methyl benzoate. That means okay, this is methyl benzoate. So you need to find a way how can we do this. Okay, so let us see. So if you see, this is an ester group, right? And ester groups are produced by the reactions of carboxylic acid and alcohols, right? So I know I can convert this one to carboxylic acid, and if then I react it with any alcohol, I think I'll be able to do it. This is what my thought process is. Okay, let us see. So this is not having like normal, so I'll first add here CH3Cl AlCl3. Okay, so that will give me CH3. Okay, then if I treat it with KMnO4, okay, then I will get here COOH. Okay, now if I want to treat this, I will use one alcohol like this, CH3OH in presence of H plus, right? So that one, that will definitely, I think, will convert this one to your COCH3 and we will get this ester. So that will what my work will be done here, right? Any other mechanism can we think of for esters? Yeah, this is the best method, I think. Next question, let us go. If you have any other method in your mind, please comment down. I will be checking this one. Next, para-nitrobenzoic acid. Okay, that is again very simple. You need from benzene. Okay, so first you need para-nitrobenzene, means nitro group should go to the para position. So first we will add CH3. Okay, then I will convert it into COOH group. Okay, and then you will convert it into NO2 group. Okay, so sorry, it's meta position I added. Oh, one second. Fine, so here is a mistake. Para-nitrobenzoic acid means if I first convert it into acid group, then the acid group is a meta directing group, right? So nitro will go to the meta position, but CH3 is a para directing group. So after this only you need to add the nitro group. So after this, if I do nitration, so I will get CH3 and I'll get nitro group here. Next, if I add here H plus, not H plus, yeah, KMnO4, sorry, that is your oxidizing agent. If I use KMnO4, okay, just a minute, yes. Now if I use KMnO4 here, then what I'll get? I will get here COOH and this one I'll get as NO2 group. Okay, so here what is there? Concentrated HNO3, okay, and concentrated H2SO4. Okay, and here what you will get? CH3Cl AlCl3. Okay, let us see the next question here. Para-nitrobenzaldehyde from benzene. Okay, so first I'll take benzene, and since we need para group, so first I will introduce here CH3 group because that is an ortho para directing, right? Now if you do nitration, I will get nitro group at the para position. okay. And next we have here we need to convert it into CHO and NO2 group, okay. So now if you want to write the reagent, so first I can use here is CH3Cl AlCl3. After that what we can get? We can get concentrated HNO3, okay, and concentrated H2SO4, okay. Now once this is done, we can convert it to CrO2Cl2, okay. If you use this one, this will convert this to CHO group, okay. Fine, let us see. Okay, so students, here I want to introduce you towards the PU2 Success Blueprint Test Series. So you know, to get a top rank in KCET, only KCET marks are not enough, even board marks carry 50% weightage. So we cannot neglect this, right? So to help you with this and to help you to get 95% or above in your PU board examinations, we have launched this test series, and now this test series was actually $599, but now we have a discount season, so we are offering you this test series with flat ₹100 off at $499 price if you use this coupon, okay. So if you use this coupon, you will get ₹100 off and you can avail this test series for ₹499, where you will be getting 12 mock test papers, 4 part test and 8 full length papers. You will also be getting doubt clarification classes, one shot revision videos, and the most important thing, that is video solutions with detailed explanation, right? So everything is just at $499. So do not delay. If you want to buy it, please go and click on the registration link and given in the description section and purchase it. Remember, the last date for this discount is December 28th. So just few days are left, students. So please do not forget and just grab this opportunity. Fine, let us go to the next question here. You have to convert to meta-nitrobenzoic acid, okay. So if you have meta-nitrobenzoic acid, so this is very simple. First I will introduce CH3, okay, then I'll convert it into COOH, okay, and then we can convert it into meta-nitrobenzoic acid by just giving nitration, because the reagents are here meta directing. So first I can do CH3Cl AlCl3, then here I can use like KMnO4, okay, and then here you can use concentrated HNO3 and concentrated H2SO4, okay. Fine, next is phenyl acetic acid, okay. So that means from benzene, okay, benzene to phenyl acetic acid. So you have like this, I think. No, sorry, phenyl acetic acid we want. Okay, so phenyl acetic acid, okay. So we need to create this one from here. So I can do like this. So first of all, we can introduce one CH3 group here. So I'm just writing the steps how I'm thinking this one, okay. CH3 I'll introduce, then I'll make it CH2Cl, okay, then I will make it CH2Cn, and then I can get this one, right. I hope all of you would have got the answer now, because we have introduced one more carbon. So what I can do here is, this is simple your alkylation. So we will get what? CH3Cl AlCl3. Once this is done, to chlorinate you can just use Cl2H nu, okay. Once you chlorine to get KCN, you can just use KCN, and to convert this one you can just use H plus, right. Okay, next question, how will you bring about the following conversions in not more than 2 steps? Okay, this is very important. You just have 2 steps to do these questions, okay. Propanone to propene, okay. So we have propanone, this is propanone, and we can use only 2 steps, right. So I can have only 2 steps here, and this one has to be propene, okay. So first you can see, if I do reduction. Okay, so if I just use NaBH4 for reduction, then I will be getting CH3 CHOH CH3, and then to remove this double bond or to remove this OH and H to get this double bond, I can treat it with alcoholic KOH, right. So what it will do, it will remove H and OH and will get double bond. Next, ethanol to 3-hydroxybutanol. Okay, so if I have ethanol, means you can see CH3 CH2OH, okay, and you get 2-hydroxybutanol, 3-hydroxybutanol. So I need to draw the structure like this. 1 2 3 3-hydroxybutanol. Okay, 1 2 3 4. Okay, so to get this compound, we have 2 extra carbons, right? So what I can do, can we get this through aldol condensation? Is it possible? Because no, in aldol condensation we get beta unsaturated compounds, alpha beta unsaturated compounds. Okay, let me think, just a minute. I think this one should come from aldol condensation only. First let me convert it into an aldehyde, right? So if I use PCC, so what I'll get, CH3COH, right? Now if I'm reacting this one, okay, for aldol condensation, then what should be the product? I have taught you the trick to find the product for aldol condensation, right? So I can do like this. So you will get like this one compound, and you can erase here. We will get CH3, yeah, here it will be OH. Those who do not know about this trick, you can watch my detailed KCET video on aldol condensation on this chapter. I have taught you. So you can get 1 2 3 4. Yes, so we need for aldol condensation, I need dilute NaOH. Okay, so do not put heat here. If you put heat, if you give heat, then you will get alpha beta unsaturated alkenes, right? So that is why this has to be the answer. Next is benzaldehyde to benzophenone. Okay, you have benzaldehyde, okay, and you want benzophenone. One second. Okay, benzaldehyde to benzophenone, right? Okay, so how can we do this? What I can do is I can react one phenol to this group. Okay, let me react one phenol to this group, or we can use Grignard reagent. Okay, let me use a Grignard reagent like phenol MgBr. Okay, so this is minus, so this one will attack here and this one will come here. So first what I will get here, one alcohol will form, right? So I have this one, then I have OH, then I have H, okay, and to this C we have this phenyl group. Okay, next to OH to C double bond O, what we need to do? We need to do PCC. Okay, so this one will what will say oxidize the OH group and C double bond O will take part. Next we have benzoic acid to benzaldehyde. Okay, so if you have simple benzoic acid, okay, and to benzaldehyde, okay, benzaldehyde. So if I reduce this one, right, we will directly get benzyl alcohol, CH2OH. Okay, so I can use LiAlH4. You reduce this to alcohol and then you use PCC and oxidize it to aldehyde. Okay, that can be done. So nothing is going more than 2 steps. Benzene to meta-nitroacetophenone. Okay, so we have benzene, okay, and meta-nitroacetophenone. acetophenone, right? Metanitro, yes, metanitroacetophenone. Okay. So first of all, what I can do is I can add this COCH3 group by Friedel-Crafts acylation, right? CH3 COCl AlCl3. So what will this do? This will add your, okay. Next, this is an electron withdrawing group. To add nitro, what you will use? Concentrated HNO3, okay, and concentrated H2SO4, okay. So this one will give you nitro group at the meta position, okay. 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 So next question is from benzaldehyde, okay. So if I have benzaldehyde to 3-phenyl propane 1-OL, okay. So that means we have CH2OH, CH, CH2, and like this 3-phenyl propane 1-OL, okay. So now if I want this benzaldehyde and if I just react it with CH3CHO, like I'll do aldol condensation with dilute NaOH, okay, then what I'll get here, this one will attack on this one, so I'll get a compound like this. I will get here COH, okay, then I'll get CH2 and CHO, okay, but I'll also heat it. So if I heat this, there will be an alkene formation here, right? So I'll erase this and I'll get one alkene here, okay. Now if this one is there and I just treat it with hydrogen and nickel, then what will happen? All this will be reduced and you will get here one OH group here and we'll get CH2, CH2, this one, right? So we have 1, 2, 3, 1, 2, 3 carbon, okay. So if you use here any NaBH4 or LiLH4, then only this group will be reduced to alcohol, okay, but this group won't be reduced. So to reduce both double bond and the aldehyde group, you need to use hydrogen and nickel, okay. Fine. Now let us do next question, benzoic acid to metanitrobenzyl alcohol, okay. So this is also very simple. You have benzoic acid already, okay, and you need metanitrobenzyl alcohol. Metanitrobenzyl alcohol. So this is simple. First you can add nitro group, okay, so convert it into nitro group, okay, and once this is done, just reduce this one to using LiAlH4, and here you can use concentrated HNO3 and concentrated H2SO4, okay, done. Let us see the next question here. Bromobenzene is there, okay, bromobenzene to 1-phenyl ethanol, okay. So the structure here you should be very careful. CH3, here OH, and here you have phenyl, okay. So 1-phenyl ethanol. Now what I can do here is I can just treat it with Mg and ether and convert this to a Grignard reagent, okay. So you will get like this, it's MgBr, okay, and after that you can treat it with CH3COH, okay. So this one will be plus, this one will be minus, you attack on this one, you take this OH group here, okay. So you will get this group here, right, just the attack of Grignard reagent. Let us see the next question here, benzaldehyde to alpha hydroxyphenyl acetic acid, okay. So we have this one, that is your benzaldehyde, okay, and we have phenyl alpha hydroxyphenyl, okay, alpha hydroxyphenyl acetic acid. Now what we can do is simply you just treat HCN here. So once you treat this one, what we will get, you can get here OH and CN, right, and after this just use H plus and this CN will get converted to COOH. Next, benzoic acid to metanitrobenzyl alcohol. So this is also very simple. You have benzoic acid, okay, and you have here metanitrobenzyl alcohol. So I have this one, meta-nitrobenzyl alcohol. So first I can do nitration first of all. Okay, so if I do nitration, I'll get NO2 group here, and then if I do nitration COH to CH2OH, you just can reduce it by using LiAlH4, and here you can use concentrated HNO3 and concentrated H2SO4. Okay, fine, that's all. Now we will go to the next chapter, that is amines, and we'll do the conversion questions from this chapter. Ethanoic acid to methenamine. Okay, so first see, whenever there is a loss of carbon, okay, you can see that there is a loss of carbon or there is a reduce in the number of carbon. So always remember it should be something related to Hofmann bromamide degradation. Okay, so if I use Hofmann bromamide degradation on this particular compound, CH3CONH2, okay, and for that what I need, Br2KOH, right? Then this part will go and I'll get this one, and for getting this one what I need CH3COCl, and on this compound if I add NH3 I will get NH2. Next, from here to here how can I get? Just simply by treating SOCl2. Okay, SOCl2 will replace HNCl and we will get this conversion, right? Very simple. Next question, hexane nitrile to 1-aminopentane. Again, that is a first is hexane nitrile, right? So we have CH3, CH2, 4, okay, and CN, right? I can say like this, 4, 5, 6, okay. Then to pentane, 1-aminopentane. So if you have CH3, CH2, whole 3, 3, 4, and 5th carbon is having NH2 group, sorry, I have NH2 group here. Okay, so now first what I can do, I can convert it to acid, simply just use H plus, and we will get here CH3, CH2, whole 4, COOH, right? Got this one. So again there is a reduction in the number of carbon, so same thing we will do, just treat it with SOCl2. So what I will get, CH3, CH2, whole 4, okay, then you will get COCl. After that if you just treat it with NH3, then what I will get here, CH3, CH2, whole 4, okay, CONH2, okay. Next, just to remove this CO group you can use bromine and KOH, okay, fine. Next question, methanol to ethanoic acid, number of carbon is increasing, right? So here what I can do, methanol, CH3OH, first I will convert it to CH3Cl, then I will convert it to CH3CN, and then I will convert it to CH3COOH, right? So if you know the reagents, quickly tell me. OH2Cl I can use SOCl2, Cl2CN I can use KCN, and here I can simply use H plus, right? Let us see the next question, that is your ethanamine to methanamine, okay. So again there is a less number of carbon, so you can guess that there must be some involvement of Hofmann bromamide degradation, right? So we have ethanamine to methanamine. Okay, now if I have from ethanamine to, if I want to convert here, I can convert it into alcohol, right? And from alcohol I can convert it into acid, right? Then I think we have done the work. Now you can convert it to CH3COCl, okay, then you can convert it into CH3CONH2, and then you can convert it to here, right? So what is the reagent required here? Here you need nitrous acid, right? So HNO2. Then here you need what? Convert it into acid, so that is alkaline KMNO4. Okay, next for doing this one you have to use SOCl2, and then for doing this one you can use ammonia, and here we are left with bromine and KOH. Okay, Next is ethanoic acid to propanoic acid. Number of acids is increased, right? Number of carbons has increased here. So CH3COOH to propanoic acid. You have CH3, CH2, CH3, CH2, COOH. Okay, fine. Let us do this. First, let us convert it into alcohol, right? So if I use LiAlH4, so what I'll get? CH3, CH2OH. Then convert it SOCl2 and convert it to CH3, CH2Cl. Then use KCN, okay, and convert it to CH3, CH2Cn. Okay, once you got 3 carbons, then simply use H plus and convert it into propanoic acid. Okay, next question, methanamine to ethanamine. Okay, you are increasing the number of carbons. So we have CH3NH2, okay, and we want CH3CH2NH2. Okay, fine. So first what we'll do, convert it into alcohol. Okay, nitrous acid if you use, you will get CH3OH. Okay, now once you got this one, convert it into CH3Cl, then convert it into CH3C triple bond N. Okay, once we have got this one, then we need to convert to this one, right? So you can use Na and C2H5OH. Okay, sodium amalgam if you use, Cn can be converted to the reduction of Cn can take place and you can get this compound. Okay, so what are the reagents required here? Here we can use SOCl2 and here you can use KCN. Okay, next question, nitromethane to dimethylamine. Okay, you have nitromethane, okay, and we need dimethylamine. Okay, this is dimethylamine. Okay, so nitromethane, what I can do, just we can use SnHCl, okay, and convert it into NH2. Okay, next you just need to treat it with CH3Cl. Okay, if you treat with this one, what will happen? One of the H will be replaced with CH3 and HCl will be a byproduct. Okay, next, propanoic acid into ethanoic acid. Number of carbons has decreased here. So we have here CH3COOH. Okay, propanoic acid to ethanoic acid. 1 second. Okay, CH3CH2COOH, propanoic acid to ethanoic acid. Okay, fine. So what we can do here is, okay, first we can just do decarboxylation in presence of NaOH and CaO. Okay, so I will get what? CH3, ethane I will get. Okay, next we will use Cl2, so that will give me Cl2 in presence of H nu, that will give me CH3, CH2Cl. Then you can treat it with KCN. Okay, that will give me CH3, CH2 and Cn. Okay, and once you got this one, one second, decarboxylation, I got 2 carbons, right? Okay, fine, here I did a mistake. We do not have to get again 3 carbon, right? So what I can do is just treat it with aqueous KOH. Okay, so you will get CH3, CH2OH, and then you can just do oxidation. Okay, what you can use, like KMnO4, this is a primary alcohol, so with KMnO4 you will get as ethanoic acid. Okay, see, there can be many methods, okay, but I am telling you some of the methods which is using more reactions. Okay, there can be many shorter or longer methods as well. Okay, next is nitrobenzene to benzoic acid. Okay, nitrobenzene to benzoic acid, nitrobenzene to benzoic acid. Okay, what we can do here is nitro benzene to benzoic acid. Okay, I think this one will be following your benzene diazonium chloride, what I feel. So first what I'll do, I'll convert, see this one I can get from here. If I get CH3, I can get it from this one. This one I can definitely get it from benzene, right? And benzene I can get from N2 plus and Cl minus, okay, benzene diazonium chloride. So what I'll do, from benzene diazonium chloride, okay, one more step is that benzene diazonium chloride I can get from NH2, okay. So NO2 to NH2 I can use SnHCl, okay. Then once I get this NH2, what I'll do, I'll treat it with your nitrous acid, okay. Nitrous acid will give you N2 plus and Cl minus. Then you can treat it with water to get one H here, okay. Then you can treat it with CH3Cl and AlCl3, and after that you can get here KMnO4, okay, done. Next question is benzene to metabromophenol, okay, benzene to metabromophenol, okay, that is a interesting question here, okay. So first what I'll do, I'll introduce nitro group here, okay. I introduce nitro group. Once I introduce nitro group, then I will introduce bromine group, okay. Why I am doing, because nitro is a meta directing group. So if you introduce bromine, it will come here. Next what I'll do, I'll convert it into NH2 group, okay. So actually I will need one more step here. One second, let me write it here. Okay, so I'll get here NH2Br, okay. Next I will get N2 plus and Cl minus and Br. Next I'll get this one, okay. So you have here concentrated HNO3 and concentrated H2SO4. Then you have SnHCl, okay. Then we have here NO2 to sorry, here I have bromination, right. So for bromination you can use Br2 FeBr3, okay. Then here I will use SnHCl. Then NH2 to N2 plus Cl minus, you will get HNO2, okay. Next from here to here you can just, you have to add OH, so I can use H2. H2 if you use, you will get this one, okay. Let us see the next question, that is benzoic acid. One second. Okay, so we will get benzoic acid to aniline, okay. So we have here benzoic acid, and then I want aniline from here. So you can see number of carbon is reduced, right. So if one carbon is reduced, then definitely it is which group? It is your Hofmann bromamide degradation. So you have COCl, okay, and after this you have CONH2, okay, and after that you have bromine KOH. So COH, if I just treat it with SOCl2, then you will get ammonia, okay. Then you will get here Br2 KOH, okay, done. Next is aniline to 2,4,6 tribromofluorobenzene, okay. This is interesting question. So you have aniline here, okay. First you need to get 2,4,6 tribromoaniline, okay. So if you have NH2, then you just get 2,4,6 tribromoaniline. After that convert it into benzene diazonium chloride, okay. Again you just use it, fluorine and bromine. Next you just need to convert it into fluorine, and we know in the reactions of this one, that is benzene diazonium chloride, how to get fluorine, right. So here what you have to do, simply you have to use bromine water. Okay, once you got this one, then just use HNO2. Then once you get this one, use HbF4. Okay, next is benzyl chloride to 2-phenylethanamine. Okay, so it is benzyl chloride, then you have 2-phenylethanamine. Okay, 2-phenylethanamine. Okay, so now if I have this group, I can just convert it into KCN if I use. So I'll get CH2 C triple bond N. Okay, now you just can reduce it using lithium aluminium hydride. Okay, done. Next question is chlorobenzene to para-chloroaniline. Okay, so you have here chlorobenzene and you have your para-chloroaniline. Okay, so first you can do nitrobenzene, right, because chlorine is an electron with it is a ortho-para directing, so we will get nitrobenzene, then you can just convert it into NH2 group, right, and here also you can just use concentrated HNO3 and concentrated H2SO4. Okay, next aniline to para-bromoaniline. Okay, this is difficult, or this is a tricky question, because aniline, if you just treat it with bromine, right, you will get what, 2,4,6 tribromoaniline you will get, but the question is asking only for para-bromo, means only one substituent is required. So for getting that, what you need to do, you need to deactivate this amino group. Okay, so how to deactivate it? So just treat it with CH3COCl. Okay, so what will happen, this one will give you a group like this, that is NHCOCH3. Then if you do just bromination, okay, Br2 in presence of acetic acid, okay, then what you will get? You will get a bromo at the para position, right? So we will get here bromine, and here you will get NHCOCH3. Then once this is done, just use H plus and this group will be reduced to NH2 group. Okay, next is benzamide to toluene. Okay, so you have benzamide, right, that means CONH2. Okay, benzamide to toluene. Toluene. Okay, so first what I can do, you can just use here Br2KOH, okay, and you can get aniline from here. Okay, now after getting aniline, just convert it into N2 plus and Cl minus. After getting N2 plus and Cl minus, just convert it to H. Once this is done, convert it into CH3Cl, AlCl3. Here you can use water with H3PO4. I will add H here, and here you can use HNO2. Okay, one second. Here you can get HNO2. Okay, like this, if you convert, you will directly end with toluene. Let us see the next question, that is aniline to benzyl alcohol. Okay, so suppose you have aniline here, okay, and you want to get what, benzyl alcohol. Okay, so I want like this, benzyl alcohol is OH. Okay, so this I know that I can get this one from, if I have COH group, if I reduce this, I'll get this one, right, and this one I can directly get from this one, right, and this one I can get from, so if you remember the reactions of benzene disonium chloride, that is very, very important. It is used to prepare so many things. Okay, so here I can use HNO2, then you can use here CuCN, KCN. Okay, then here you have to use H plus, and then here you have to use lithium aluminium hydride. Okay, so that's all, and you will be getting the conversions. So that's all students in this class, and I hope you would have enjoyed all these 30 questions. You would have done it. If not, you just practice it. Okay, there can be different methods of preparation as well. Okay, so if you have any doubt in any question, please comment down. I'll definitely address it. And thank you so much, and see you soon in the next class. And do not forget to subscribe the channel if you have liked this video. Thank you.